I'm Dr. D.K. Tripathi, going to start today nanomaterials. Now, before going to the nanomaterials in detail, we should have a view of the lecture given by Richard Feynman, who is known as the father of nanotechnology. But before that, let us have just a very uh, brief idea about the nanomaterials. Nanomaterials means, you see the word nanomaterials. It is composed of two words, nano plus materials. Nano means 10 to the power minus 9. And materials, that means if a material is having any dimension in the 10 to the power minus 9 meter dimension, then that very material is called as nanomaterial. But later on, this has been defined as if any one of the dimension of a material is in between 1 to 100 nanometer, then that will be called as nanomaterial, like our hair. So nanomaterials are or nanoparticles are the set of particles or materials or substances where at least one dimension is less than approximately 100 nanometer. In 1959, at first, Richard Feynman has given the idea of nanomaterials. And after 25 years of that, he has again told about the same technology due to which the miniaturization is possible. So let us see this lecture. Richard Feynman, who was born in 1918 and died in 1988, on December 29th, 1959, at Caltech, Dr. Feynman addressed the American Physical Society with the lecture was named as There's a Plenty of Room at the Bottom. His classic talk about the future of design and engineering at the molecular scale. 25 years later, on October 25th, 1984, Richard Feynman gave that lecture again during a week-long experimental seminar in Caltech, and that lecture was named as Tiny Machines. So after 25 years, what he told, let us hear that. He is Professor Richard Feynman. So he is talking about that how small we can write that, and he is proposing that if complete, he is proposing that anyone can write on an atom. The size of the atom is 10 power minus 14 meter. He is proposing that if complete Britannica encyclopedia can be written on the tip of the pen, Is it possible? Now it is possible. So you should have the uh, viewing of this complete lecture. Let us go to our lecture. Now, the benefit of nanotechnology depends on the fact that it is possible to tailor the structure of materials at extremely small scales. Tailor. What the tailor is doing? He is joining the two parts of the cloth. Here also, what will happen? The two parts of the bands will be joined together. How? We will discuss it later in the quantum effect. What happens actually that in any material there is, or in any semiconductor, what happens that there is valence band, and above that there is a conduction band, and in between there is band gap. So if we can decrease this band gap between the conduction band and the valence band, then the conductivity of the material will increase. So how we can do that? Just by tailoring this band gap. So I will give you this concept later on, but here for the sake of understanding, you just think that the benefits of the nanotechnology depends on fact that it is possible to tailor the structures of materials at extremely small scales. So at extremely small scale, just you have heard about Feynman, he is saying that if anyone can write on an atom, on a single atom, if writing can be possible, or the whole Britannica's encyclopedia can be written on the tip of the pin. Is it possible? So he has proposed all these in 1959, and in after 25 years of that, when the transistor has been evolved, he was giving the lecture again, which whose URL is this one, and he told that yes, it is possible. The circuitry, when in 1950s, what happens, that size of the computer was like the size of a room, but in 1970s, in the decades of the 70s, the computer got miniaturized. So this is because of the miniaturization, and the things which are created, or you can say that fabricated at lower scale, that is more stronger, lighter, more durable, more reactive, more sieve-like, or better electrical conductors can be used there. So all these properties are there. Now, what is the importance of this nanomaterial? Why we are learning this nanomaterial? This is also very important thing. We are learning the nanomaterials because we have seen that the properties of the materials got changed when they are taken at the nanoscale. As we know that the um, gold, it is non-magnetic, but at nanoscale it becomes ferromagnetic. High magnetic power is seen there. So it can be used for the storage devices at that very level. Or the color of the gold is yellow at bulk level, but at the nano level, the colors got changed. So what are the importance of the nanomaterials? This can be understood easily if we can understand that where these are used, what are the applications of nanomaterials. So that we will discuss in fourth lecture, but just for simplicity, for understanding, I'm saying you that everywhere in everyday materials, these nanomaterials are used, like in the fabrics. Nanomaterials are used which can uh, tell you that what bacteria is sitting on you, or this can preserve you from any type of viruses. This can have a sensor. So there it is used, or it is used in the smartphones so that its storage can be increased. Not only storage, in the batteries, the batteries which will be made with the use of nanomaterials, that will be used there, and that will be charged within 5 minutes, and that charge will last for 5 or 6 days. It is proposed now, and nanomaterial batteries made with nanomaterials are available in the medical and healthcare applications. the surgery tools are made of nanomaterials and they don't have any rusting. So, and these are also lighter. There is no risk of any type of, um, you can say that, tetanus or any other problem when the surgery is done with the help of nanomaterials. In the case of energy applications, the blades of the windmills are made of nanomaterials, which are lighter in weight so that more amount of electricity can be produced. And as the nanomaterials are not giving any exhaust, actually with the help of nanomaterials, it is tried to convert the carbon dioxide from the point of origin into carbon and oxygen. So in the environment it can be used, and in people are using this in the case of synthetic fibers. So these are the different applications which we'll discuss in detail, that what are the applications. We are not aiming this in this in this lecture. So let us proceed with that, that all materials in nanoscale size have quite large. What is the specialty about the nano materials? Why we are getting the different properties? This is because of the that if nanomaterials, that means 10 power minus 9 meter is the dimension of the um, body or particle at that level, then what happens actually, that most of the very less number of atoms are there, and because of that quite a large surface area is there. That means surface area to volume ratio is very high, and because of that they are showing different properties. These characteristics opens a way for new quantum mechanical effects. Due to these effects, the size of the particle reduces, which causes a change in the electronic properties of the solid. So electronic properties will be changed because electron can be regulated now. Actually what happens, that if you are going to the nanoscale, very less number of atoms are present there, so most of the electrons which are on the outermost orbit, that becomes the surface electrons. So these surface electrons can be regulated from the outside, and because of that they can show the behavior which we want. So there is a drastic change in the properties when the material changes from macro scale, that means large scale, to nanoscale. These changes are unique and can be used for a variety of applications. How these changes, what happens and how we are getting the changes, let us have a look. Copper is actually opaque material, but if you go to the nanoscale it becomes transparent. Platinum is inert. You know that the jewelries are made of gold and silver, and platinum is used to make that. Why? Because it is inert, no reaction is there, but it becomes catalytic at nanoscale. Aluminium, it is stable, it cannot be combustible, but at nanoscale it becomes combustible. Gold, which is a solid, this becomes liquid, and also the color changes, the magnetic properties changes. Silicon is insulator, or better to say semiconductor, and at the nanoscale it becomes conductor because of tailoring of the band gap. So what is the use of reduction of dimensionality? We have seen that when we reduce the dimension, the properties of the bulk materials got changes, and it is acquiring the different properties. So when one or more of the dimensions of a solid are reduced sufficiently, its physiochemical characteristics, physicochemical properties means physical as well as chemical, both properties, as well as magnetic characteristics depart from those of the bulk solid. With the reduction in size, the novel electrical mechanical, novel means new, new characteristics, electrical, magnetic, chemical, magnetic, and optical properties can be introduced. The resulting structure is called a low dimensional structure. The confinement of the particle. Confinement means when the particles are confined in a range, that means it cannot come out of that. It is purely under it. Usually electrons or holes, because both of them are used as the charge carriers. To a low dimensional structure leads to a dramatic change in their behavior and to the manifestation of size effect that usually fall into the category of quantum size effect. Quantum size effect that I will deal in the second class. So the low dimensional material exhibit new physico-chemical properties not shown by the corresponding large scale structures. Nanostructures constitute a bridge between the molecules and bulk materials. You see what happens actually if nanomaterials are used, suppose for Howrah Bridge, if nanomaterials are used for making the Howrah Bridge, it will last for millions and millions of years. So the strength will be very, very high. It will be rust free. Many things are there. So what are the different properties? Let us discuss. Magnetic nanoparticles are used in range of applications. Those nanomaterials which are having the magnetic properties, like in imaging, bioprocessing, refrigeration, as well as high storage density, magnetic memory media. Before this, we have learned about the storage and display devices. So nanomaterials can be used for making them. They can store more amount of information and for a longer time. The large surface area to volume ratio results in a substantial proportion of atoms. That means a large amount of atoms having different magnetic coupling with neighboring atoms, leading to the different magnetic properties. Bulk, gold, and platinum are non-magnetic, just I told you, but at the nano size, they act as a magnetic particle. Gold nanoparticles becomes ferromagnetic when they are capped with the appropriate molecules such as thiol. Giant magnetoresistance, GMR, is a phenomenon observed in nanoscale multilayers consisting of strong ferromagnet. Strong ferromagnet, what are the strong ferromagnet? Iron, cobalt, and nickel. And a weaker magnetic or non-magnetic buffer. Weaker magnetic material are uh, chromium, copper. It is usually employed in data storage and sensing. So what happens that when this giant magnetoresistance is the phenomenon which is observed between the strong and non-magnetic material, so, or weaker magnetic material. So that phenomenon is used for data storage and sensing at nano level. In small nanoclusters, the effect of reduced dimensionality on electronic structure has the most profound effect on the energies of highest occupied molecular orbital, HOMO. You see, the full form is highest occupied molecular orbital, which is valence band, and the lowest unoccupied molecular orbital, LUMO, essentially the conduction band. The optical emission and absorption occurs when the transition of the electrons occur between these two states. So these are the two states, LUMO and HOMO. And the optical emission and absorption occurs when the electrons are transiting from higher to the lower, there will be optical emission. And when the electrons are transiting from lower to the higher, then at that level, then what will happen? There will be absorption. Semiconductors and many metals show large changes in optical properties, such as color. Optical properties, what are these? Colors are changes in semiconductor when we are going from bulk to the nanostructure. Colloidal suspensions of gold nanoparticles have a deep red color, which becomes progressively more yellow as the particle size increases. So we have seen that in gold is yellow in color, but at nano level, it is deep red color. So color is also changing. So let us have some uh, observations about the change, what happens actually. Gold spheres of 10 to 20 nanometer exhibit red color, whereas the bulk gold is having the yellow color. Gold spheres of 2 to 5 nanometer, you see the size is reduced further. From 10 to 20 nanometer, it is 2 to 5 nanometer. These exhibit yellow color. And gold spheres of uh, greater than 20 nanometer exhibit purple color. Like that for silver. Silver particles of 40 nanometer exhibit blue color. Silver particle of 100 nanometer exhibit yellow color. Prism shaped silver particle is red in color. So what we know actually, the silver is having the white color, but here the color is changing with the size. So different other physicochemical reactions are or changes are seen in the case of photocatalysis, photoconductivity, photoemission, and electroluminescence when the particles size is changing from bulk to the nano size. Now the electronic properties. What happens to the electronic properties when we reduce the size, when we are going from bulk to the nanoscale? The changes which occur in the electronic properties as the system length scale is reduced are related mainly to the increasing influence of the wave-like property. At nano, from higher to the, we know that de Broglie hypothesis. So from de Broglie hypothesis, we know that any material is having both the characteristics, and we also know that as we go from bulk size to the lower size, then the wave-like properties is going to increase. So here also what happens that when we go to the bulk to the nanoscale, the wave-like property of the electrons and the scarcity of scattering centers is there. At first, the wave-like property is going to increase. There will be more influence of wave-like properties, and the scattering centers becomes less and less. That means there will be less number of particles which can collide and scatter the electrons. As the size of the system becomes comparable with the de Broglie wavelength of the electrons, the discrete nature of the energy states becomes apparent once again, although a fully discrete energy spectrum is only observed in systems that are confined in all three dimensions. In certain cases, conducting materials becomes insulator below a critical length scale as the energy band ceases to overlap. Owing to their intrinsic wave-like nature, electrons can tunnel quantum mechanically. That we will also discuss. You have learned this in the quantum mechanics, the tunneling effect. Actually, what happens that the electrons which are confined to a potential well, they are crossing that potential well and going to the other region. This is called as quantum tunneling. You have learned this in quantum mechanics. So quantum tunneling will be seen there. So due to that, quantum tunneling current will increase. So electronic properties will be different. The particle which is non-conductor, or you can say that a weaker conductor, that becomes conductor at the nanoscale because of this tunneling effect. Conduction in highly confined structure, like in quantum dots that we'll discuss, is very sensitive to the presence of other charge carriers and hence the charge state of the dot. These Coulomb blockade effect results in conduction processes involving single electron, and as a result, they require only a small amount of energy to operate a switch, transistor, or memory element. This is very important thing. The Coulomb blockade effect results in conduction process involving single electron. A single electron can have the small amount, which is having small amount of energy, is sufficient to operate a switch or a transistor. All these phenomena can be utilized to produce radically different types of components for electronic, optoelectronic, and information process applications, such as the resonant tunneling transistor. This is very new concept. Resonant tunneling transistor and single electron transistor. A single electron will operate the whole transistor. So overall, what we can see that if we go from bulk level to the lower level or nano level, then what we can see, small size effect, because of the small size effect, or which is called as quantum size effect, that will be seen. That means due to this quantum size effect, now what is non-conductor or weaker conductor, or we can say that bad conductor, what is not having the magnetic properties, all this will be achieved. At low level or nano level, the material contains very small number of atoms, and because of that, their properties can be regulated. Electromagnetic forces are dominant. You see, if take your example, that if this class size is 60 or 100, then and the second situation, that if the class size is 240 or 300, which can be regulated in better way, the class in which the number of student is less. So same thing is here. If the number of atoms got reduced, then they can be regulated from the outside. For let us have an example. Suppose I am saying to you that you just make the scatter plot, or you make the bar graph of all first divisioners in secondary level examination conducted by your state board. So what will happen? When you will make the bar graph, or when you will make the scatter plot, you will not be able to identify that which you will not be able to state correctly the whole result. But if I'm saying you that don't do that, you plot this graph for your district, then graph will be more better. Your prediction will be more and more better. Now, if I reduce this problem and saying you that you make for your block, then you will be able to tell more better or predict more better. But if I'm saying you that you just plot it for your school only, from where you have passed, you will be able to tell that what are the how the result is changing from years to years, how many students are first divisioners, how many students are second divisioners, and all the informations. So what happens if you come to the lower size, reduced size, then the prediction becomes more and more better, because you can regulate in better way now. So the same thing happens here, that if at the bulk level, million and trillions of atoms or molecules are there, which will be reduced in the nanoscale. So less number of atoms are there, and because of that, their behavior as well as properties will be different, and also you can regulate them because of coming of the atoms or molecules on the surface. So electromagnetic forces are dominant. Wave particle duality, that is seen. Quantum confinement is there. This we'll discuss later on. And discrete energy levels are present. So these are the changes when we proceed from bulk level to the lower level. Now let us have an idea of types of nanomaterials. Different types of nanomaterials are there. First one is on the basis of occurrence. That means where we are finding them. So on the basis of occurrence, then types of nanomaterials are classified into three types: natural, incidental, and engineered. You see, natural nanomaterials which are existing naturally, like viruses. Viruses are, you see, this one. This is the structure of capsid. Okay, or protein. Viruses are what? Viruses are proteins. So this is the structure of capsid, which is naturally occurring nanomaterial. Wax. You see the wax on the lotus leaf. This is a nanomaterial. Size is very, very small. spider mite, butterfly's wing. You see, this is the structure of the butterfly wing. This is naturally occurring nanomaterial. Milk, blood, skin, claws, beaks, feathers, horns, hairs, papers, all these are natural nanomaterials. You see, spatula, this spatula of bottom of the gecko feet, this is made of nanoparticles. So these are the nanomaterials. So these are naturally occurring nanomaterials. Our hairs, naturally occurring material, nanomaterial. It's only one dimension, that is length, is having very high value, whereas the other two dimensions, the hair is three-dimensional. So out of that, the other two dimensions are in nano range. Incidental. Incidental nanomaterials means those nanomaterials which are not occurring naturally and they are not engineered. They are formed because of some physical or biological reactions or chemical reactions or mechanical reactions. These nanomaterials are called as incidental. Like the exhaust of the engine. In the exhaust of the engine, the smoke is coming. Or when you are doing some experiment in chemistry lab, fume is coming. So this is the structure of fume. Or when you are using some domestic solid fuel for heating and cooking, the fume or smoke is coming. That is incidental. Your aim was not to create the smoke. Your aim was not to have to produce the fume. Your aim was not to have in the running of the engine, what you are doing. You are trying to run the engine so that your work becomes easier and easier. Your aim is not to produce the smoke, but smoke is produced, which is a nanomaterial. So it is incidental one. The third type of nanomaterial on the basis of occurrence is engineered one. Engineered one means the nanomaterials which are produced in the labs or factories. So they are very much systematic and they are having all the properties which I discussed. So the example of this is carbon nanotube. Probably all of you have heard about CNT. So carbon nanotube, quantum dot, nanomaterials, graphene. You see this fullerene. Fullerene is what? This is having greater than 60 carbon atoms attached in a sequence. So these are called as fullerenes. Carbon nanotube, you see. Quantum dot, it is having dot-like structure. That is why it is called as quantum dot. Nanoparticles, graphene sheet, and dendrimer. So these all are the engineered nanomaterials. In the next class, we will discuss about the nanomaterials on the basis of number of dimensions in the nano range. So these are the references which you must go through to understand in deep about all these things, because nanoscience and technology is very new branch and you can have the better scope there. So you must go through them. And lastly, thank you.